For lesson 3.5 in geometry, which is the equations of parallel and perpendicular lines. The first thing that we need to examine when reviewing this is the notion of slope. Slope is represented mathematically by the variable m. Slope is noted to be the vertical rise over the horizontal run, rise over run, which is going to be calculated through a vertical change in the y-axis, the vertical axis, over the change in x, the horizontal axis. That little triangle next to y and x, for the record, is the Greek letter delta, which represents change. The way that we calculate that change is we're going to subtract y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Now, what's also permissible is that we can do this in reverse order. It always has to be y over x, but we could do y sub 2 minus y sub 1, as long as we're subtracting the second x, x sub 2, minus the first x, x sub 1. So as long as we're consistent in our order of 1 minus 2, 1 minus 2, or 2 minus 1, 2 minus 1, always y over x, we will get the same exact outcome for slope. Let's review calculating slope. So we're going to find the slope of the following 2 points. It's going to be of -1, -5, and 1, negative 4. Now we're going to denote that x -1 is going to be an x. It's always alphabetical in a coordinate plane, right? X comma y. So x sub 1. So since that's the first x, right, and this is the first point, everything else is going to have a name. -5 will be y sub 1. 1 will be x sub 2. -4 will be y sub 2. Okay? And then we can calculate using our formula. So m is equal to. Now I'm going to encourage you that whenever that you are going to replace variables into an equation, that you do so in parentheses. So we're going to say, instead of just y sub 1 being y sub 1, it's going to be -5 in parentheses minus -4 y sub 2, and then over x, right? X sub 1, which is -1, minus 1. We're going to have fewer calculation errors this way, so we don't drop any negatives. -5 plus 4 over -1 minus 1, which is -2. In other words, we have -1 over -2, which is equal to positive 1/2. There's your slope. Now, just for the record, just for fun, we're going to do this reversing what's our first point and our second point. So we're going to call this guy x sub, not x sub 1, but we're going to call him x sub 2. Taking this y sub 2, this x sub 1, and this is y sub 1. Okay? So when we do that, equaling, and rather than -5 minus 4, we're going to say -4, right? Minus -5 over our x sub 1 is going to be 1 minus 1. Okay, so -4 plus 5 minus is plus over 1 plus 1, which is going to give us 1 over 2. It's the same exact thing. Okay, doesn't matter which way you do it. You only have to do it one way, but both results will yield the same thing. When we have parallel lines results are going to have the same slope versus perpendicular lines. The slopes are going to be the negative reciprocal. So for example, if my slope is 3, the perpendicular slope is going to be -1/3, right? You take the opposite and then you're going to flip it over, right? If I had -1/2 as my slope, then my perpendicular slope will be +2. Or even if I have -5 over 4, right, as my slope, my perpendicular slope will be +4 over 5. So just a couple examples on how we get that perpendicular slope. Let's take a look at a problem here. So let's go ahead and graph in a coordinate plane. And the only way deductively for us to identify whether or not something is parallel or even perpendicular is we can't just kind of eyeball it. That's not going to work for us. We have to prove it. And if we employ the slope formula, okay, so this first guy here is going to be -3, 1. If we employ the slope formula, we're going to be able to see if our slopes are matching. So 6, 1, 2, 3, 4. That's 6, 4. Okay, so let me move that. So now connect my lines. 6, 4. Does it go through my plotted point here? I'm gonna have negative 0, negative 1, 2, 3, 4, 5, 6, 7. And then I'm gonna have 8, 7, 8, negative 2. This is 0, negative 7. This is 8, negative 2. Now, right now, it doesn't look like they're parallel, right? But it doesn't matter. It looks like they eventually could intersect somewhere in that first quadrant. It's not illustrated, though. Now, what we need to do is actually plug both of these points into the slope formula and see what we're going to yield, okay? Or both sets of points to calculate two separate slopes. I just drew my own coordinate plane, so I could just have a sketchy drawing, right, that shows that they're gonna, it looks like they'll intersect, but it might not be the case. So let's go ahead and calculate. M is equal to, I have my x sub 1, y sub 1. I'm gonna label my points. Makes sense to do so, why not, right? So I make fewer mistakes, so I can transfer directly over 1 minus 4 over negative 3 minus 6, which will give me 1 minus 4 is negative 3. Negative 3 minus 6 is negative 9, which is going to reduce to positive 1/3. My other slope, okay, it's going to be m, where we have x sub 1. So let's do it the other way around. Why not, right? Let's make this guy the first x. So you can just show that we can go in the other order and it's still going to yield the same thing. And I have negative 2, right? Minus 7 over 8 minus 0, right? So this is negative 2 plus 7, really, minus over 8, or 5 over 8, okay? So in conclusion, the thing that we need to show is that the lines are not parallel, and the reason why is because they have different slopes, okay? Matching slopes would mean they're parallel. Since they're not, these are not parallel. All right, let's practice a couple things. Let's write an equation there we go, of the line passing through the point negative 4 comma 6, that is parallel to the line y is equal to 3x minus 4. Now, to complete this, we have to remember that if we're going to write an equation, the function form is what is also known as the slope-intercept form of y is equal to mx plus b, okay? Remember that m is what we use to represent slope, but b is the y-intercept, okay? Now, we have all the elements of this to actually complete this problem, except that we don't have a y-intercept, right? We actually have an x, we have a y, and we even have a slope. Because remember, if my slope is parallel, it's going to have the exact same one as this line, so we're going to steal this slope right here of 3 to use for our new equation, okay? So my y, again, is 6. My m is that stolen slope, 3. And my x is negative 4, all plus b. And we're going to solve for b here, right? 6 is going to be equal to negative 12 plus b plus 12. Oops. Plus 12. Cancels. 6 plus 12 is 18, and that's my b. Okay? So we're going to take this guy, y equals mx plus b. I've got my b here, so I know that y is equal to my stolen slope, 3x plus 18. This is my new equation that will be parallel, since it has the same slope, just using a different y-intercept, because in that equation, it will include this point right here, negative 4 comma 6, because we already plugged it in. So it has to include it. All right. Next, let's write an equation of the line passing through point negative 12 comma 6 that is perpendicular to the line y is equal to 2/3 x minus 10. All right. Sometimes when we steal parts, we have to modify them a little bit, okay? So this is going to be our stolen slope here, but our perpendicular slope is going to be negative 3 over 2, not just positive 2/3, okay? Again, we're doing a perpendicular line. So, of course, y is equal to mx plus b, okay? So here's my x and here's my y. So 6 is equal to m, my stolen m, right, that I modified, negative 3 halves. X is going to be negative 12. And then we're going to do plus b. So we're just doing some substitution. These guys are going to factor out, right? So I'm going to have 6 is equal to negative 3 times negative 6 is going to be positive 18 plus b minus 18 minus 18 cancels, and then I'm going to have negative 12 is going to be my b. So bring this guy back over here. Y is going to be equal to, again, my stolen modified slope, negative 3 halves, x. And then my new b is minus 12 when I found it. And there we go. That's my answer. All right. This next problem is a doozy. It's going to be about 1 page of work, okay? This is going to utilize a bunch of skills that we already have, right? I already just wrote distance, so you should know the distance formula is coming up. And we're going to take the distance from a point to, then our point in this case is 6 comma negative 2, to a line, y is equal to 2x minus 4. Now remember, the shortest distance to any given point that we have is going to be through the perpendicular slope, okay? Or excuse me, not through the perpendicular slope. It's going to be a perpendicular line. Now, if we figured out where the perpendicular line going through that point and the original line, this guy, are going to intersect each other, then we have two lines will intersect each other at exactly 1 point, and we can take that point and our original one and use the distance formula to calculate what that distance is. Okay? Now remember how we find where two lines intersect, it's going to be through a system of equations. So, should be reviewing some old Algebra 1 skills. Steal that slope, right? And we're going to modify it. It's going to be negative 1/2. So, y is equal to mx plus b, right? And we're on our way. Here we go. X and y. So my y, negative 2, is equal to my m, negative 1/2, times my x, which is 6, plus b. All right, so negative 2 is going to be equal to negative 1/2 times 6 is negative 3. And to get b by itself, it's going to be 1. Right? And there we go. My new equation, y is equal to stolen modified slope, negative 1/2, x. So I'll have my independent variable x, right? I input there to get my output from my dependent variable y, and then plus 1 as my b. Now, I have two equations here, right? I have my original one, y is equal to 2x minus 4. And I have this new one, y is equal to negative 1/2 x plus 1. That 1 a little bit better. Now, think about this algebraically. Both things are equal to y, therefore these two equations are equal to each other. Okay? Do this in black here. 2x minus 4 is going to be equal to negative 1/2 x plus 1. So I went from having two equations and two variables, and now I only have one equation and one variable, which, as you guys are great at solving, right? So we now just need to solve for x, and we'll use that to get our y, right? So plus 1/2 x to both sides. These guys cancel, okay? So 2x plus 1/2 x is going to be 5/2 x minus 4 equaling 1. Add 4 to both sides. So I'm solving for x, trying to get it by itself. 5/2 x. If you're wondering where I got 5/2, it's 2.5, right? 2 plus 1/2 is 2.5. And then the improper fraction is 5/2. And you'll thank me in a moment why I wrote it as an improper fraction, right? Because now I'm going to get rid of it, and it's one step. I'm just going to multiply by the reciprocal, 2/5, right? And all those guys are going to factor out on the right. And in fact, on the left and on the right, even the 5s are going to factor out, leaving me with x being equal to 2. So I got to plug this guy back in, and you can do it to either equation. You'll get to be the same outcome. I'm going to put it in that one. I think it's easier, right? For me at least. So I'm going to do 2 times 2 minus 4, right? Because I'm better at just multiplying integers together rather than multiplying times a fraction. So y is going to be equal to 4 minus 4, which of course y is now equal to 0, okay? Which is going to give me my coordinate. Now, for the record, if I'd plugged 2 into the other one, this is just for fun, I mean, just showing us that y was equal to, if I did it as negative 1/2, right? plugging in the 2 plus 1, it's going to have the same result, right? Negative 1/2 times 2 is negative 1 plus 1, which is going to be 0. It's the same exact deal, okay? So my coordinate is 2, 0. Sweet. Now, go back. Think about the original problem. We need to find the distance between this and this guy, my new coordinate, okay? So this is really like a new problem almost that I have here, where I now need to, my new objective is I need to find the distance between 6, negative 2 and 2, 0, okay? And here's how we do it. D, distance, is equal to difference of my x's, 6 minus 2 squared, plus the difference of my y's, negative 2 minus 0 squared, okay? 6 minus 2 is 4 squared, plus negative 2 squared, right? This is just a distance formula. Okay, I'm kind of going through it quickly because we may need to review what that is, so you're going to have to review your notes. How to do the distance formula. 4 squared is 16, plus negative 2 squared is 4. Square root of 16 plus 4, which is rad 20, and that can reduce, of course, to 2 rad 5. This is our answer, gentlemen. This is what we've been working for the entire time. Do not give me a decimal. I want the exact answer. If you have any questions, feel free to contact me. Good luck.